Welcome back to Pre-Algebra, Chapter 9, Section 3 in this book. And what we're going to talk about today is the Pythagorean Theorem, thought of thousands of years ago by an old Greek guy. One time I saw, I'm always reading about education and trends and stuff, and there was this idea that we needed to rename the Pythagorean Theorem because the kids would be turned off by that old Greek name, and we needed to call it the Fred Theorem or something. I disagree. I think kids like knowing some fancy Greek words, some fancy Greek names. It makes them feel smart. So I don't want you to be intimidated by Pythagoras' old name, his old Greek name. I want you to be empowered by you knowing what the Pythagorean Theorem is and feeling smart. An interesting thing about the Pythagorean Theorem is that there are things in math that we understand before we can prove why it works. And this is one of those. It was used for literally thousands of years until our American president, James A. Garfield, came along before he was president and he proved it. Isn't that weird? He was a president. He was a brilliant mathematician. He could write Latin with one hand and Greek with the other at the same time while thinking it in English. The guy was freaky smart. He got assassinated too. Interesting. You should go read an article about him. Anyway, so the two people about the Pythagorean Theorem, Pythagoras and Garfield, which makes you think of the cat who likes lasagna. All right. Not always, that's just not my favorite comic. Garfield, never has been. All right. So this is his theorem. There is a relationship between the three sides of a right triangle. Right triangle must be a right triangle for this to work. That one corner has to be 90 degrees. Then, on this triangle, it will have three sides. One of the sides will be longer than the other two. The long side is called the hypotenuse. That's fun to say. I had a girl who was an 11th grader in trig, and she would call it the hippopotamus. And I would be like, what are you talking about, hippopotamus? And she said, the long side of the triangle, the hippopotamus. It's not hippopotamus, it's hypotenuse. Similar, but slightly different. Okay, the two short sides are called the legs. That's kind of funny, isn't it? It doesn't matter which one's the A leg or the B leg, but C, for this whole thing to work, must be the hypotenuse. I almost said it must be the hippopotamus. All right, so this is the theorem. The relationship. If you square A and add it to the square of B, it equals the square of C. So it's A squared plus B squared is C squared. Here is an example. I have a triangle and the three sides are 3, 4, and 5. But let's pretend we didn't know that this was 5. And we're going to figure it out. Okay? We're going to just call it C. Okay, so we've got our two legs and we want to find out what the hypotenuse is. So we sing the song, substitute, and we substitute into our formula. 3 is get substituted in for A, 4 for B. And I could have done 4 for A and 3 for B. And the legs don't matter, just the hypotenuse. Okay? I substituted in. Now, I simplify this side. 3 squared is 9. 4 squared is 16. I bring down what I didn't mess with. Now I add these together. 9 plus 16 is 25 equals C squared. Now I'm to my question. What's my question? Why is X not alone? But this time it's C. Why is C not alone? It's squared. So I do the opposite. What's the opposite? Square root. What I do to one side, I do to the other. The square root of C squared is C. Because now it's got a twin. There's two C's in Arkham. One gets out. There he is. 25 is made out of 5 times 5. One burns in acid, the other one gets out of jail. So the square root of 25 is 5. So 5 is our hypotenuse. Now, remember how sometimes we have to say plus or minus? We don't have to say plus or minus here because it's a distance, it's a length, and those are not negative. I don't say it's 2 miles from my house to the library and negative 2 miles from the library to my house. Nope, it's still 2 miles from the library to my house. So distances are not negative. I know there's a physics book that teaches different, but just believe me, distances are not negative. Okay, here is Another one. One with big numbers. Can we do it if there's big numbers? Yes, we can, Bob the Builder. But we just use our calculator. All right, so C is the long one. So we were going to do a squared plus b squared is c squared. 212 squared plus 478 squared equals c squared. I don't know my 212 tables up to 2, so I'll use my calculator. And I don't know my 478 tables up to 2, so I'll use my calculator, then add them together. Now, why is c not alone? It's squared. What's the opposite? Square rooted. What I do to one side, I do to the other. And this is not, if I do it on my calculator, it's not what's called a perfect square. Something doesn't perfectly get out of jail the way the 5 did with nothing left over. So on my calculator, it's going to give me a decimal just zipping on across that screen. I round it off and I say what it is approximately equal to. Instead of c equals 5, because it was a perfect square. Everything got out of jail. But this one not. So it gets approximately equal. Okay, here's another one. This time what we're missing is a leg. We have one leg and the hypotenuse. Here's my little right triangle. So I sing the song, substitute, and substitute it in. Instead of A, I changed it to X because I'm dyslexic and that A is too much like a 9 in my brain. X's are much better for me. So X squared plus 10 squared equals 12 squared. 10 squared is 100, 12 squared is 144. I do know those. So now, why is X not alone? Well, it's got 100 and a squared. We work from what's further away to what's closer. What's the opposite of that? Plus 100 minus 100. What we do to one side, we do to the other. Those cancel out. 144 minus 100 is 44. Why is X not alone? It's squared. So what's the opposite? Square rooted. So this is not a perfect square. 44 is made out of 4 times 11. 4 is made out of 2 times 2. So 11 stays in jail. 2 gets out and 2 gets dissolved in acid. So the answer is X equals 2 times the square root of 11. If we want to know what it approximately equals, we put that in our calculator and it'll tell us a decimal approximation. Okay, the last thing we do with this is sometimes they'll want you to know, is it a right triangle? Like how Rhett and Link do, will it taco? Will it right triangle? Fellow YouTubers. Okay, so if it is a right triangle, then a squared plus b squared will equal c squared. If it's not a right triangle, it won't. So I have one right here to try. One side is 3, one's 5, and one's 7. So I put it in my formula. 3 squared plus 5 squared. Does it equal 7 squared? Ooh, the suspense. Let's do the next part. 3 squared is 9, 5 squared is 25, 7 squared is 49. Is 9 plus 25 49? Ooh, we don't know. 9 plus 25 is 34, and 34 does not equal 49, so no, it is not a right triangle. If it had been a right triangle, they would be equal. And there's an example in your book like that, you can see. Alright, so that's Pythagorean Theorem, not too hard. Once you get to Algebra 1, I will want you to have the TI-84 graphing calculator, and I will want you to have a Pythagorean Theorem program and one for find leg. If you can get to me with your calculator, I've got the plugs and I can give you those programs. If not, they're out there in the internet land. You can find them and get them for your calculator, all right? But you don't have to have it this year because I don't require the TI-84 until Algebra 1. All right, math is great. See you next time.